Yeah, good evening, students. Today I am going to discuss symmetry of molecules. In the symmetry of molecules, what is the concepts of symmetry? The term symmetry is derived from the Greek word symmetria, which means measured together. Symmetry is a kind of balancing act. Symmetry is a phenomenon of a natural world as well as the world of human inventions. Symmetry is all around us and is a fundamental property of nature. Symmetry refers to beauty of an object, that is aesthetic concept. Most of the objects in the nature looks beautiful because of their symmetry. Symmetry greatly enhances the beauty of the nature. For example, see here some objects of the symmetrical and some are the asymmetrical. See these red color, someone is the symmetry and another one is the asymmetric. There are some rough figures: equilateral triangle, square, rectangle, Picasso triangle, rhombus, circle, etc. There are three lines of symmetry. There are four lines. Square is four lines of symmetry. Rectangle has two lines of symmetry, and icosahedra one lines of symmetry. Rhombus and two lines of symmetry, and circle is a infinity lines of symmetry. So there are some pictures and in flowers, animals like this, and butterfly also have some symmetry. In our famous arts college, Osmania University building also have some symmetry. That is why this is looks beautiful. And another in Hyderabad, man-made environment in Charminar, it's also symmetrical structure. And Lotus Temple, it's also symmetrical structure. And Taj Mahal look beautiful because of their symmetry. Eiffel Tower look beautiful because of their symmetry. And Petron's Towers in Malaysia, these are an Indian Parliament. So all these look beautiful because of their symmetry. Now let's look into the concept of symmetry of molecule. The term symmetry also refers to the geometry of molecules, that is a scientific concept. All objects, living, non-living, are made up of molecules. These molecules have certain geometrical shapes. The concept of geometry can be discussed in terms of symmetry. The symmetry concepts and its related groups, theory and extremely useful to rationalize and simplify many problems in chemistry. Number 1. It predicts the number of fundamental bonds in IR and Raman spectra. It predicts the number of stereoisomers of a given molecule. It predicts the type of orbitals involving bonding. It predicts optical activity of molecules. It explains the electronic spectra and molecular orbital theory of metal complexes. It explains the number of additional properties of molecule and assigning term symbols of d orbitals in crystal field splitting. A molecular model kit is very useful to understand the symmetry of molecule. So overall concept of symmetry is like that their application. So what is the symmetry? It is difficult to answer this question, but one can feel the symmetry in an all its possible aspects. It can be rather explained, illustrated as a property of geometrical figure. It can be defined in a user-friendly manner as any molecule or object is said to be symmetrical if it can take up one or more equivalent configuration by performing some geometrical manipulation on it. For example, water molecule. It is having two hydrogen, one oxygen molecule. The original configuration shown in the structure 1. When we rotation the 180 degrees of anticlockwise rotation, there is a give another structure that is a equivalent configuration but not a same. Yeah. Another example, BX3 molecule. When we rotate the 120 degrees of rotation, it will give three structures, and 1 and 2, 2 to 3, 3 to 4. and 1 and 4 1, 2, 3 are equivalent configuration, whereas 1 and 4 are identical configuration. In order to understand the symmetry of molecules, one should familiar with the symmetry operation and symmetry element. These two are intricately related, that is, one does not exist in the absence of another. Symmetry operation, it is a geometrical manipulation of on the molecules. When performed, results an equivalent or indistinguishable configuration of the molecule. For example, consider H2O molecule. See, every 180 degrees rotation will give the another structure. 1, 2 are equivalent configurations, 1, 3 are identical configuration. There are three symmetrical operations. One is a rotational about an axis, reflection in a plane, inversion through a point. In order to perform the symmetry operations on a molecule, one should be familiar with the following. One, shapes of the molecule are to be known. Two, coordinates are either linear, either bent. Three, coordinates are trigonal, planar, or T-shape or trigonal pyramid. Four, coordinated tetrahedral, disparate seesaw structure and a square planar. 5, coordinated are trigonal bipyramidal, square based pyramidal, pentagonal planar. 6, coordinated octahedral structure. 7, coordinated pentagonal bipyramidal. 8, coordinated square and prismatic. These are the some structures which is coordinate to their number, depends upon their number. Atoms or groups in the molecules are assumed to be in a free state. Center of gravity should not be altered during the symmetry operation, holding up the molecule in a proper orientation. So, symmetry elements. A symmetry elements is a symmetry elements. A symmetry element is a geometrical entity exists within the molecule. It can be axis, it can be plane or a point in the molecule, and it is generated by the corresponding symmetry operation. In molecules, there are 5 types of symmetry elements which can be generated from the 3 types of symmetry operations, elements and operations. Rotational axis, Cn, n-fold of rotation. Plane of symmetry, reflection, sigma. Improper rotational axis, Sn, improper rotation. Center of symmetry, which is shown I, inversion center. Identity element, which is indicated by E, identity elements. Okay, these are the some symmetrical concepts.